واحد. Hi Alif. I usually don't do, I don't see like any new ideas in workshops, so I don't do them, but this one is a little bit intense and there are some ideas in it. First question, they're given this matrix, and is it in the span of this? Like, can you make a linear equation using these matrices to make up this? So what we do, and watch carefully, we say, well, there could be a constant, C1, times this, plus another constant, times the second one, plus another constant, times the third one, plus another constant, times the last one. And the last one is 1, negative 1, 1, 0, negative 1, negative 1, 0, 0. You need, since you have 4 unknowns, you need 4 equations. So if you go 1C1, look, 1C1, 0C2, minus C3, and 1C4, this must equal the first position here, 1. So we have an equation. Let's see if we can have another one. 0C1, 1C2, 0,3, negative 1C4 must equal position 2, which is minus 2. Let's look at the third position. 0C1, 1C2, negative C3, 1C4 would equal minus 2. We need another equation. So let's look at this number 1. I think it was 0. Yeah, this number in the matrix was 0. So let's look at this number. 0C1, 0C2, 0C3, 0C4 equals 0. That's not an equation. So you skip. You go to the fifth position, the 3. 1C1, 0C2, 1C3, negative 1C4 equals 3. Now once we have the 4 equations, 4 unknowns, we hope that none of them is repeated, like they're all different. If they're all different, you take this and you turn it into a matrix. So this column C1, C2, C3, C4, and coefficients are 1, nothing, nothing, negative 1. Answer is, what am I doing? So I will do the first equation. 1, 0, negative 1, 1, and the answer is 1. We do this equation. 0, 1, 0, minus 1, minus 2. We do this equation. 1, or we do this one first. Doesn't matter. 0, 1, minus 1, 1, minus 2. And finally, we do this one, which is 1, 0, 1, negative 1, and 3. And you reduce this to find the answer. So I don't remember what the answer was. But when you reduce it, whether you reduce it Gauss or Gauss-Jordan, doesn't matter. I believe the answer was something like this. I don't know. So, we know now that C1 is 2, C2 is 1, C3 is minus 1, and this one is 2. Now you know that this works for the first 5 because that's how we generated the equations. You gotta try it for the 6th one to see if it works, or the 7th one. Since I don't have what the right answer was, it's hard for me to check, but I checked it, and yeah, this is, yes, it is in this band, and this is the values, or how they're linearly connected. Okay, the second question you're given 4 matrices. I'm only doing 3 here. It was in the question you had 4. And are they independent? Like all 4 of them independent? So you think, well, do we really have to reduce this to get to see if they're independent? No, this is an introduction into a concept called finding the determinant. So, I'll show you the structure. It's a 3 by 3. So you start positive, negative, positive, negative, positive, negative, positive, negative, positive, so you alternate. And it doesn't matter where you start. So if I find the determinant, for example, for this, and you've probably seen it before, it doesn't matter where you start. But try and benefit from the fact that this is 1, 0, 0. So I start with the 1, that's positive 1. So if I pick 1, then that cancels this column and this row. I only have these 4 left. So I go 2 times 6, 0 times 2. Then this number is negative, but it's 0, so it doesn't matter. And this number is positive, so 0, it doesn't matter. So the answer is 12. So the determinant is 12. That's not 0. That means it's independent. Anytime the determinant is not 0, it's independent. So let's do it, for example, for this. I'm going to start from this column. So positive 0. So that doesn't matter. This, a negative 0, but it doesn't matter. And then we go to the 9, which is positive. 9, hide this row, this column, so 2 times 3, and 0, 54, not zero, independent. Let's do the last one. It doesn't matter, I start here, 2, 44 minus 0, a negative 0, positive 0, answer is 88, not 0, independent. Good? So this is how you deal with this. Like even, let's say, we know that the determinant is 88. If someone chooses to do it in a different way, choosing this column, it would be positive 0, doesn't matter. This one, negative 0, doesn't matter. And you go to this one, it's positive. Hide this and this. 2 times 4 is 8, minus 0, and 11 times 8 is 80. So either way you do it, in any column or any shape, you get a determinant of 88, not 0, independent. So that's a quick way of deciding whether a matrix is independent. It always benefits from the rule that's all zeros. And then you got a question C where you need to simplify. Simplifying this, AB transpose, BA transpose, transpose. I'll do the inside. AB transpose would be A transpose, B times B times A transpose. And transpose, A transpose is A, B transpose is B, B transpose is B transpose, A transpose transpose is A, and there is no either or more you can do here. Like a matrix sum is transpose, you can't really do anything there, so you leave it as it is. This is the simplest form. There are more. I'll do this in part 2. Thanks.